Okay, as a follow-up to the Pythagorean theorem, we're going to be looking at the distance formula here. The distance formula is based off of the Pythagorean theorem. And the way we use the distance formula is to calculate the distance between 2 points where we may have some a rectangular coordinate grid or a rectangular system. So the distance formula gives us a measurement, which is distance. And this is equal to, this is the square root of, and the square root of x2 minus x1. I should see these as a sub. Yeah. X sub 2 minus x sub 1 squared, okay, plus y sub 2 minus y sub 1 squared. So we take the square root of our second order pairs x minus first order pairs x. We square the difference there. Then we add the difference in the y's squared. Then we take the square root of that. That gives us the distance between 2 points. So let's look at an example here. Say we have 2 points. We'll say -3, 2, and I'll make this one a little further away. 7, -4. Okay. So if we want to find the distance between these points, well, what we got to do is we got to sit up and say, okay, we're going to have a big radical sign here. And we know we have, we'll say this is 1 and this is 2 over here. So x2 minus x1. So we have 7 minus -3 squared plus y2 is -4 minus 2, minus 2 squared. So now we're going to work inside out, doing our order of operations. We'd have 7 minus, okay, -7 minus -3 is the same as saying 7 plus 3 squared plus -6 squared. Okay. So 7 plus 3 is 10, so we'd have the square root of 10 squared, and we know -6 squared, -6 is in parentheses, so -6 times -6 is 36, so 100, or 10 squared plus 36, which is the square root of 100 plus 36. So we'd be looking at the square root of 136 here. Now, that isn't a perfect square, but can we break it down? Well, let's see. We could say 2 times, what do we have there? 68, right? 2 times 68, so we could do 2 times 2 times 34. So we could do 2 times 2 times 2 times 17. 17 is prime number. So we've really got the square root of 4 and the square root of 34 here. Okay. And the square root of 4 is 2, so we're looking at 2 square root of 34 would be our answer for what is the square root of 136. Or what is the distance between the points -3, 2, 7, -4 is 2 times the square root of 34. So that's the distance formula. There's a couple other formulas we have that we'll see here and there, where, well, let's do another distance formula, and maybe I'll talk about another one of these formulas somewhere. So let's say we want the distance formula, and we want to find the distance between the point 36 and the point 511. Okay. Again, remember, we're going to have the square root of x2 minus x1 squared plus y2 minus y1 squared. So here we'll say, now we'll reverse this, that's 1, that's 2. So we have x2 is 3 minus 5 squared plus 6 minus 11 squared. This is the square root of 3 minus 5, -2 squared, plus 6 minus 11 is -5 squared. So really we're looking at the square root of 4 plus 25, which is the square root of 29. So that's our distance between the points 3, 6, and 5, 11, be the square root of 29. A couple other formulas we're going to see, just to throw these in here for fun for a minute. We can see, let's see, a velocity. If an object falling a certain height, the velocity of that object, velocity is equal to the square root of 2g8. G is acceleration of gravity, and h is the height fallen. If something's falling, we can use this to figure things out. On Earth, if we look at Earth, I think it's 32. Acceleration of g on Earth is 32 meters per second, or 32 meters per second squared is the acceleration of that. We can also use different methods here with regard to radicals for solving like a square-based pyramid. If we have a square-based pyramid, which we have a pyramid, and it has 4 sides, not 3, so if we look down, we'd see a 4-sided pyramid looking down on it. If we have a 4-sided pyramid, and this is a square base, is what we would do. We can say there's a formula that's b is equal to the square root of 3v over h. And what this is the length b of one side of the base. So if we take the length of one of these bases, that's b. Okay? The volume is v and the height is h. So when we look at this, we can find what b is with the volume of the period. Say the volume of the period pyramid, 24 cubic feet, and the height is 2 feet. So if we look at this, we want to say, well, what's the size of the base of this? Well, we can look at this and we can say we have 3v here, or 3 times our volume over h. The size of our base is equal to the square root of 3 times 24 is 72 over 2, which means we're looking at the square root of 36. The size of each side there would be 6 feet? I think this, 6 feet, we get 2 feet here. So the size of the base would be 6 feet. So we can use radicals in a lot of instances to solve problems. A lot of things are based off Pythagorean theorem and distance formula. So hopefully this helps with the distance formula, and I'll see you in the next video. Have a good day. Bye.